Your video. All right, guys, this is your video notes about the Pythagorean theorem, the converse of this. So this is just kind of what can we use the Pythagorean theorem to prove. And so these are what these video notes are going to be going over with. When you've completed these video notes, you will have then your homework right here, which is the second page. It even says homework, so this will be right here. This will be due Tuesday. You can use those notes for you. Also, then, if you look on the board and also that little slip that was been given to you, you have some IXLs that you can work on, R4, R5, and the other one N4, as well as that will be due Friday as well. So those will be able to help you do these, okay? So let's go ahead and get started about what the Pythagorean theorem converse is and what exactly it does. So basically a converse in this case is just basically the reverse. And it tells you right up here in the top, it says it switches the if, so it switches the order of the if and then statements. And what I mean by that is when if comes first, like in the first one right here, it says if a triangle has 3 equal sides, then it's an equilateral. Well, the converse is just the reverse of it. So what that means is we're going to be switching these two statements. So said this one went first, it's going to go last. And this one, since it went last first, it's going to go first. So what we do is we just rewrite it here. It says if a equilateral triangle then it has 3 equal sides. So all we did was just switch it. Alright? Same thing here for our next one. It says if a number is even, then it is divisible by 2. So here's your first one, and here's your second one. So we're just going to flip the reverse of those. That's basically what a converse does. It just says, okay, if a number, we just say, okay, if this is true, then this is true. So then I can reverse it. So it says if a number. So let's see here. If a number is divisible by 2, then it is even. So what does that have to do with the Pythagorean theorem? Well, remember, the Pythagorean theorem works with right triangles. And so if we know that the Pythagorean theorem a squared plus b squared and c squared only works for right triangles, and that the two legs added up when I square them is equal to the hypotenuse squared, and that works for only right triangles, then I can reverse it by saying that if a squared plus b squared equals c squared, then the triangle is a right triangle. Because remember, it says I can only use this theorem for right triangles. So if a right triangle, then a squared plus b squared equals c squared. So if I flip it around and say, if this is true, then the triangle must be right triangle. So this helps us prove if triangles are a right triangle or if they are not a right triangle. So basically what we're going to do is we're going to find the legs and the hypotenuse, and we're going to see if they both match up to become equal. So this is kind of, let's see what an example is put forward here. So here's my first triangle. I want to see, it looks like it's a right triangle, but let's see if it is. We don't know for sure. So the first thing I want to do is I want to label my things. I'm going to say that's my hypotenuse because it's the longest side. These are my legs. So I'm ready to set this thing up, and I'm going to see if the a squared plus the b squared is equal to the c squared. All right. So let's see here. If I fill in what I know, I have 84 squared plus 13 squared. It should equal 85 squared. So this side right here has to equal this side. And if they do, it's a right triangle. So let's see what happens. If I put that in my calculator, 84 squared and plus 13 squared. Let's see what happens. 84, let me put it in here, 84 squared plus 13 to the second power gives me 7225. So 7225. Now let's see what 85 squared is. So I'm going to put in 85 to the second power. That also gives me 7225. So these are now the same. So this is, yes, it's a right triangle. Okay? So far I know that's a right triangle because both sides are the same using the converse. So let's look at number 2. I'm going to do the same thing. This is my hypotenuse because it's the longest side, 21. These are my legs. I'm going to see if this is a right triangle. Write down what I know. I know my formula. I got to use this, and I got to prove. I got to see if this side can match that side. So let's write down what we know. We know it's 15 squared and 12 squared. See if it equals 21 squared. All right? So if I put 15 squared plus 12 squared, so that's going to be 15 to the second power plus 12 to the second power, gives me 369. Let's see if 21 to the second power is the same thing. So 21 to the second power, oh, it's 441. Those don't match up, so we say, no, that's not a right triangle. So we know that it is not a right triangle. We know that this angle is not, that is not 90 degrees. Okay? Number 3, let's take a look at this one. So here we go. This is my hypotenuse because it's the longest side, 45. These are my suspected legs. Let's see if it is a right angle triangle or not. So I'm going to put it in here. A squared plus B squared equals C squared. I put in my A, 30 squared. My B is 15 squared. And my C is 45 squared. Remember, this side has to match this side to be a right triangle. That's what I'm just trying to see. So I'm going to put it in here. 30 to the second power plus 15 to the second power gives me 1125 for this side. So let's see what 45 to the second power is. They have to match up. If it doesn't match up, I know it's not going to be a right triangle. So 45 to the second power is 2025. Oh, too big. It won't work. So that's a no. This is not a right triangle. So this right here is not 90 degrees. So I know it's not a right triangle. Okay? Number 4, if you do the same thing again, just label your sides. Find the hypotenuse first. It's got to be this guy because he's the longest side. Hypotenuse. C. Legs. A and B. Longest side, hypotenuse. The rest of those are your legs. Fill in what we know. Write down the formula. I know you guys probably say, this doing too much, but it's okay. If you do it and you get it right the first time, you don't have to worry about redoing it or complaining about it. Just take your time. So I got 18 squared and 24 squared. I'm going to take the square root of the square of those. So 18 to the second power plus 24 to the second power. That equals 900. So this side right here is 900. Let's see what 30 to the second power is. Let's see if it's also 900. If it is, then we know it's a right triangle. So 30 to the second power is also 900. So now I know, check, yes, right triangle. So this is a right triangle. There is a right angle. This is 90 degrees right there. So I know it is a right triangle. So that's what basically the converse is saying. If both sides are the same, then you know it's a right triangle. If both sides are different, then you know it is not a right triangle. Okay? Let's flip the page over and take a look at the last couple ones here. So here you have a table here. They're asking you if it's a right triangle and then to prove it. Okay, so here we go. So basically what you have is you've got a size, you got a triangle of 12, 24, and 36. So if you drew something out here, you've got 36 because it's the longest. You got 12 and 24. And let's just prove it. Let's see if 12 squared and 24 squared is going to be 36 squared. Well, let's do this. Let's do the math. This is my hypotenuse because it's the longest side, and then these are my legs. So let's just put it in here. 12 squared, 12 to the second power, plus 24 to the second power, gives me 720. 36 to the second power gives me 1,296. That's a no. So this is no. Same thing with the next one. 6, 9, and 11. Just kind of draw a picture. 16 is my hypotenuse. It's the longest. 9 and 11. Label it C, A, B, or whatever you want to put it. But there's your hypotenuse. 16 is the longest side. So I want to see, using my converse, to see if it's a right triangle, because I use the Pythagorean theorem, see if this works out to be the same. So I got 121 and 81 when I put that together. So here we go, 11 to the second power plus 9 to the second power gives me 202. And then I try the 16 to the second power, gives me 256. These do not work out, so this is a no. There's my proof. Okay? I do the same things with the other ones. If you need to set it up, there's your right triangle. The longest side is 29, so he's your hypotenuse. 20 and 21. And I just set it up using my converse. It says, hey, if the Pythagorean theorem is working, it's a right triangle. So I got to see if this side matches up with the 29 to the second power. Put it in here. 20 to the second power plus 21 to the second power gives me 841, I'm sorry. And if I do the other one here, 29 to the second power, 841. So that matches up. So this is a yes, that is a right triangle. And the last one here I have right there is my hypotenuse because it's my longest side at 12.5. That's my C. The other ones are my legs because they're shorter than my 12.5. So I just put it in here, 7.5. I want to see if it's a right triangle. So I use the Pythagorean theorem. And remember, this side has to match up with that side. So let's see what this side is, and we'll see what this is and see if they match up. So 7.5 squared plus 10 squared gives me 156.25. Let's see what 12 to the 12.5 to the second power gives us. 15625. So they match up, and since they match up, we know because the Pythagorean theorem only works for right angles, and since this is working and since they match up, we know that this has to be a right angle because they match up together. So there we have it. We are done. So that's basically straightforward. Here are some word problems here, basically using the same thing, just using the information to first find your hypotenuse and stuff. So we want to say, hey, Jimmy believes that this is not a right angle. So he has a triangle here that is 25, 36, and 45. So it says 25 inches, the height is 36, and the diagonal is 45. So if diagonal is 45, there's your hypotenuse. The height is 36, the width is 25. It tells us that right there in our part. C and the rest of your legs. That's the supposed hypotenuse because it's the longest side. So we're going to use the converse because we know that if the Pythagorean theorem works, then it's a right triangle. So it only works if they both sides match up. So let's see here. If I put those in here and I do my math, I get 36 squared plus 25 squared. Put it in here. 36 squared plus 25 squared. That gives me a big 1921. 1921. Let's see what the other side. It's got to match up. So I know that the Pythagorean theorem works. 45 to the second power is 2025. So this does not match up. So this is no. It's not a right triangle. Doesn't match up. Not a right triangle. Have another word problem. It says Patty wants a triangular garden in her backyard for her vegetables. She's going to use 3 pieces of fencing that measure 7, 10, and 8. What will the shape of her garden? Will it be a right triangle? So let's put it in here. So she's got a measure of 7, 10, and 8. So the longest side is your hypotenuse. So that's 10. The other ones are your feet or your legs, 7 and 8. We want to see if this is a right triangle or not. So we got to see. So we say, oh, well, the Pythagorean theorem works with right triangles only. And if this side matches with this side, we know that it's going to be a right angle. So let's see here. 7 squared plus 8 squared is going to equal 10 squared. So let's see here. 7 squared plus this is going to be 7 to the second power plus 8 to the second power gives me 113. 10 squared is 100. Nope. Not a right triangle. Doesn't work. Not a right triangle. It doesn't work. How I know it doesn't work? Because this side does not equal 10 squared. So it can't work. It's going to give me something else. So it's not going to be here. This right here should be the square root of 113. That 10 squared should actually be 10.63 whatever, but it's not. It's off by a little bit, so it's not going to be the right angle there. Okay? So that is some examples that you have for you to work on as we look at these things. Let's look at the last one. Okay? The perimeters of 3 squares are shown below. Could the 3 squares be positioned so that they form a right triangle? Why or why not? Okay? So this is the perimeter. So the perimeter is 48 feet. 140, 148. So remember, the perimeter is all the way around. So if I divide each one of these by 4, it's going to tell me what the sides are going to be. So it's just the perimeter, and I can divide these by 4 because these are squares. The squares all have the same amount on both sides. So if I take this perimeter and divide it by 4, it tells me that this side length is 12. If I divide 140 by 4, it tells me 35. And if I divide this by 4, it's going to tell me 37. And I want to see, well, if I configure these, can I get a right triangle? So what they're asking for you is if I put the side lengths of those squares together, and I say, okay, I'm going to call this one, if I put the 12 here, or the square right there with the side of 12, and I put the side right there with the square that has 35, and the one right here for 37 because it's the biggest, is this a right triangle? So I need to use my Pythagorean theorem. 12 squared plus 35 squared should equal 37 squared if it's a right triangle. So let's see. So I do 12 squared plus 35 squared on my calculator, and there it is. I get 1369. So I need the other side to match up. So let's see what happens. 37 to the second power. Yep, it matches up. So that means that the Pythagorean theorem will work. And yes, it can form a right triangle. Okay? It can form a right triangle. Alright, so there you go. Alright, so the rest, those are your notes. They've given you an example problems for these to help you to do these all throughout the problem. Okay? So if you look back at your notes, you should be able to get these, such as like number 1 through 6. This is going to be like your notes. Number 5. Draw the triangle out. Put down the numbers. Put it in the Pythagorean theorem and see if it works. Go back and look what we did, just like we did here, so you can see how we did those. Don't just go, oh, I don't know. Look back at it so you can see what happens. All right? These are all going to be like number 5. that we just looked at. So the rest of these things are the same way. Draw the triangle. Set up your equation. There's a triangle right there. Label your points. A, B, C. Same thing right here. Okay, you've got areas. Which one of these can be looking? This one, number 10, perimeter. This one will be similar, number 10 will be similar to number 8. Divide each one of those by 4 and tell me which one of these will give you a right angle. Okay, you can handle these. You should at least be able to get these right here off the bat. These two are a little challenging. So stop and think, use your notes, and you'll do okay. This will be due Tuesday. If you finish these, you can work on your IXL, R4, R5. R5 is the theorem of Converse as well. So you should be okay about these. Take your time and use your notes. Thank you very much.